Welcome to the DIY Honda Garage channel. The DTC P0101 refers to a mass airflow (MAF) sensor circuit range performance problem. This code indicates the engine's powertrain control module, PCM, has detected that the output frequency of the MAF sensor is outside a specified range. The MAF sensor plays a vital role in measuring the amount of air entering the engine, which is crucial for the PCM to calculate the correct fuel mixture for optimal engine performance. A malfunctioning MAF sensor can lead to reduced engine efficiency and increased emissions. The exact location of the MAF sensor is typically after the air cleaner, positioned in the intake air duct. If the MAF sensor fails to operate correctly, it triggers this diagnostic trouble code, leading the technician to investigate the cause of the output frequency deviation. The mass airflow (MAF) sensor is a critical component in modern internal combustion engines. Its primary role is to measure the volume and density of air entering the engine, enabling the PCM to adjust the fuel injection accordingly. Located in the intake air duct just after the air cleaner, the MAF sensor communicates the air intake data to the PCM. If the MAF sensor's output frequency falls outside the specified range, the PCM interprets this as an abnormality, leading to the storage of DTC P0101. This error typically suggests that either the sensor itself or the surrounding components in the air intake system may be compromised. Understanding the functional role of the MAF sensor is essential for troubleshooting this DTC accurately. Several possible causes can lead to the triggering of DTC P0101. First, a malfunction in the MAF sensor itself is a common culprit, which could be due to wear, contamination, or electrical failure. Additionally, there may be blockages in the intake air system that hinder airflow, affecting the sensor's readings. Damaged components in the positive crankcase ventilation (PCV) system or failures in the PCV valve and hose can also lead to improper air measurement. Finally, issues with electrical connections, such as loose or corroded wires, can disrupt the signal between the MAF sensor and the PCM, necessitating a thorough inspection to ensure reliability. Drivers experiencing DTC P0101 may notice a variety of symptoms affecting vehicle performance. One of the most immediate signs is poor engine performance, as incorrect air measurements can lead to imbalanced fuel mixtures, causing reduction in power and responsiveness. Increased emissions could also be observed due to incomplete fuel combustion prompted by the erroneous air intake readings. Furthermore, the check engine light will illuminate, alerting the driver to an issue that needs to be addressed. Other noticeable effects can include rough idling or hesitation during acceleration, both of which negatively impact the overall driving experience and the vehicle's efficiency. The first troubleshooting step for addressing DTC P0101 involves confirming the engine's operational status. Begin by starting the engine, which allows the MAF sensor to begin its data collection. Next, hold the engine speed at 3,000 revolutions per minute (RPM) without any load, either in park or neutral, until the radiator fan activates. This step tests the sensor's response under a controlled condition. Afterward, allow the engine to idle for a minimum of 5 seconds before taking the vehicle for a drive at approximately 37 miles per hour for another 5 seconds. This procedure ensures that conditions are optimal for diagnosing whether the MAF sensor is functioning appropriately. In this step, the focus shifts to inspecting the connections within the intake air system. It's essential to check the condition of the connections at various points, especially the positive crankcase ventilation (PCV) valve and hose, for any signs of damage or disconnection. A damaged PCV system can significantly affect air measurements. Furthermore, inspect the purge line and all components that extend from the turbocharger joint to the throttle body. These parts should be free from kinks, blockages, or damage. Any irregularities in this area could lead to discrepancies in airflow, which may be influencing the MAF sensor readings. Maintaining good condition in the air intake system is crucial for ensuring accurate readings. The third troubleshooting step involves a detailed visual inspection of the intake air duct and air cleaner housing. Start by confirming that the intake air duct is free from any kinks or damage that could restrict airflow. Next, assess the air cleaner housing, ensuring there are no blockages or contaminants that could affect air intake. A clear path for air to flow is essential, as any obstructions could result in inaccurate readings from the MAF sensor. Proper air intake not only optimizes engine performance, but also helps in maintaining fuel efficiency. Any findings of damage or blockage will necessitate repairs or replacements to restore the system's functionality. The fourth step in troubleshooting DTC P0101 involves confirming the readings from the MAF sensor while using the Honda Diagnostic System, HDS. Start by checking the sensor's output with the engine turned off. During this inspection, the HDS should indicate a frequency reading between 1603 and 1000 Hz. If the output falls outside this range, it indicates that the MAF sensor itself, or the intake air temperature IAT, sensor associated with it may be failing. This check holds critical importance because a faulty sensor can lead to significant engine performance issues and negative impacts on fuel efficiency. Proper monitoring and diagnostics with the HDS provide an accurate assessment of the sensor's health. The fifth troubleshooting step requires starting the engine and allowing it to idle while closely monitoring the MAF sensor readings through the HDS. This idle examination serves to ensure the sensor's performance under running conditions. As you do this, you should continue to check that the HDS displays the MAF sensor frequency within the same optimal range of 1603 to 10,000 Hz. If the readings are abnormal, it lends further evidence to a potential fault within the MAF sensor or the integrated IAT sensor. This examination is a vital checkpoint, confirming whether the components are working properly while the engine is operational, thereby impacting overall vehicle functionality significantly. Following troubleshooting and potential repairs, the final verification step involves clearing any stored diagnostic trouble codes, DTCs, from the vehicle's PCM. Once the DTCs have been cleared, it's crucial to conduct a test drive under various conditions to observe the vehicle's performance. During this test drive, monitor for signs of the original issue reoccurring, such as engine hesitation or reduced performance. Keep an eye on the check engine light, ensuring it remains off throughout the test drive. If the vehicle performs smoothly without returning to its previous state, it indicates that the troubleshooting efforts have been successful. A final scan with the HDS can confirm that no new DTCs have been triggered. To prevent issues related to DTC P0101 in the future, implementing regular maintenance practices is crucial. Begin by routinely checking the mass airflow MAF sensor, including cleaning it if necessary to remove accumulated debris that could interfere with its functionality. Additionally, it's vital to inspect all intake components, such as hoses and ducts, for wear and potential blockages. Keeping the air filter clean and replacing it on a regular schedule will ensure that the engine receives adequate air supply for optimal performance. Establishing a preventive maintenance routine not only minimizes the occurrence of similar DTCs in the future, but also enhances the overall efficiency and longevity of the vehicle. In conclusion, DTC P0101 highlights the importance of the mass airflow sensor in maintaining optimal engine performance. The diagnostic steps outlined in this guide provide a comprehensive approach to identifying and addressing issues effectively. Each step plays a crucial role in understanding how the air measurement system functions, enabling technicians to diagnose problems accurately. Moreover, incorporating regular maintenance routines, including sensor checks and component inspections, goes a long way in preventing similar errors in the future. Ultimately, a well-maintained MAF sensor and intake system are vital for the efficiency and longevity of the Honda Accord, ensuring a smooth driving experience. Please like and subscribe to the channel. See you next time.